In the last couple of lectures, I previously have described to you the mathematical details of both one and two-dimensional explosions. And as you saw, with a little bit of practice, those types of situations are usually pretty easy to analyze. Very similarly to explosions are what are called collisions. We'll take a look at a couple of different types of collisions, both one and two-dimensional. Before I do all of that, however, I want to give you an idea as to why collisions themselves are so important as a process in physics. In terms of experimental physics, collisions are really the only game in town, the only means that we know of to probe the inner constituents of matter. The basic idea is actually fairly simple and straightforward. What we do is we smash matter together at extremely high energies, at extremely high speeds, and then we basically look at all the debris that comes out during the collision itself. The greater the amount of energy that we use to collide matter together, the more finely detailed we can then look into the inner constituents of matter. In other words, we can begin to look at the universe, if you will, the nature of reality itself at extremely small scales. Now, this idea of smashing matter together to probe the inner constituents of reality does kind of lack a certain elegance. However, it is, experimentally speaking, the only game in town. But because it is considered to be an inelegant way of doing things, there's all sorts of analogies that physicists have used to describe the process. For example, somebody once described this process of smashing matter together as analogous to trying to learn about music by taking a piano and throwing it down a flight of stairs. Or like, for example, trying to learn how very finely made Swiss watches work, not by slowly taking them apart and then looking at all the stuff, but instead what we'll do is we'll take the watches and we'll smash them together at extremely high speeds and then look at all the stuff that comes out. So this idea of smashing matter together to look at the inner natures of reality does lack a certain elegance, but it is kind of the only game in town. Okay, now what you are to do at this point is stop this lecture, because then what I want you to do is immediately take a look at the three-part screencasts that I have prepared for you that take you through the brief history of physics over the last 100 years and illustrate the importance of collision experiments in physics.